Hey everyone, welcome back. I hope everything went well yesterday with yesterday's lesson. Before we start, today's assignment will be the IXL 8.z.1. The link is in Google Classroom. We're looking for an SMART score of 85 or higher for that. Today we're going to talk about functions. Yesterday we talked about dependent and independent variables and relations, okay, domain and range. Okay, so before we begin, let's do the warm-up. It has to do with independent and dependent variables, which you learned about with the ED puzzle. Remember, dependent, it depends on the independent, right? So if Frank earns $8 per hour mowing his neighbor's lawns, what depends on what? Okay, I always like to start with the dependent variable depends on the independent variable, okay? So the dependent variable is how much Frank makes depends on how many hours Frank mows the lawn. Okay? So the independent variable is the number of hours. The dependent variable is the amount of money. And for some of you who remember when we talked about this earlier, time is the ultimate independent variable. Okay? And number 2, Melinda uses 12 beads for every necklace she makes. What depends on what? Well, in this case, the number of beads Melinda uses depends on how many necklaces she decides to make. So the necklaces are the independent variable and the beads are the dependent variable. All right, so getting back to a relation. Remember, a relation is a set of ordered pairs or x and y values, right? So today we're talking about that, but we're talking about in the form of a function, okay? So relation, this is a relation. We have these set of ordered pairs, okay? And one way that we can represent this relation, if we have ordered pairs, is to graph them, okay? So we can just graph these, and we graph these ordered pairs. The first one, -1, 1. We go back 1, up 1, there's 1 pair. Then we have 2, 0, over 2, up 0. Then we have 3, 1, over 3, up 1. We have 3, 2, over 3, up 2. And finally 4, 5, over 4, up 5. And those are our ordered pairs. And now we've just graphed our relation. The other way that we can represent a relation is through a mapping diagram. In a mapping diagram, we're going to start with an input, which we know is our x, and we're also going to have an output, which we know is our y. Now, remember how when we listed our domain and range, we listed them in order without repeating from least to greatest. We're going to do the same thing with a mapping diagram. We're just going to do it vertically, and we're going to do the same thing with our range. We're just going to do it vertically. And then when we're all done, we're just going to use arrows to show which number goes with what. So we have the domain of -1, 2, 3, and 4, and we have the range of 0, 1, 2, and 5. So we're just going to write them vertically. So we have -1, 2, 3, and 4, 0, 1, 2, and 5. And then we're going to connect. So -1 goes with 1. So we go from -1 and we draw an arrow over to 1. Then we have 2 goes with 0. So we start at 2 and we draw an arrow to 0. 3 goes with 1, so we draw from 3 to 1. 3 also goes with 2, so we go from 3 to 2. And 4 goes with 5, so we draw our arrow from 4 to 5. And that's how a mapping diagram is done. And we're going to talk a little bit about mapping diagrams today, more extensively than that and what they're used for. Here is the big learn for today, and that's functions, okay? A function is a relation where each input, there is exactly one output, okay? So for a function, we can have no repeating x values, because remember, an input is an x, so we cannot have a repeating x value. Now we noticed here we had a repeating x value right here. 3 went with 1, and then 3 went with 2. Now you'll notice on a function, nothing says that you cannot have a repeating y value. It's all about not having a repeating x value. All right, so here, back to the alligators that we talked about yesterday, we have 232, 459, 565, 569, and 796. Do we have any repeating x values? The answer is yes, we do. Right here, we have an x value that goes from 5 with 65, and then we have an x value of 5 that goes with 69. Since the repeat happens there, this is not a function. Okay? Now, in here, we have a different set of alligators where we have 1 to 23, 236, 347, 461, and 573. Is this a function? Well, we look to see, did the x values repeat at all? They never did. We had a 1, a 2, a 3, a 4, and a 5. Therefore, this is a function. Now, it's usually at this point where someone asks, well, what if the x value repeats but with the same y value? If the x value repeats with the same y value, it's considered to be the same point, and therefore it doesn't count as repeating. Okay, so for example, if we added another one and it was 347, this would still be a function because 347 and 347 are the same ordered pair. It's not a repeating x value that goes to a different y value. Okay, so if it's the same x value, if it's a repeating x value but it goes to the same exact y value, that does not discriminate, it does not keep it from being a function. All right, now represent the relation as a graph and a mapping diagram, then tell whether the relation is a function and explain your reason. So I'm not going to do the map because we know how to graph it. We're going to talk about why graphing is important, but we haven't really practiced too much with mapping diagrams. I know those are new. So we're going to do mapping diagrams for these. So we start by writing input, output, and remember, it's just domain and range. It's just x and y, okay? So our input, or our x, or our domain is 0, 1, 2, 4, and 5. And our output, or our y, or our range is 3, 2, -1, 4, and 4. So we have, in order, -1, 2, 3, and 4. Remember, we don't have to write both of those 4s. Now, we have a repeating y value, but a function just can't have a repeating x value. It doesn't say anything about a y value. So do we have any repeating x value? The answer is no. This is a function. But if we want to do the mapping diagram, 0 goes with 3, 1 goes with 2, 2 goes with -1, 4 goes with 4, and 5 also goes with 4. Okay? Now, this mapping diagram is called, we would actually classify this as a many-to-one mapping diagram because you have more than one point that goes to one point, and that's okay. You can have that because, like I said, that just represents a repeating y value. There's nothing wrong with repeating the y value. Now, for number 4, we have an input and an output, and the input is just an x, which is just the domain. The output is just the y, which is just the range. Okay, so the input in order is -2, 0, and 2. And the output is -4, -1, 2, and 3. -2 goes to -1. 0 goes to 2, 2 goes to 3, and -2 also goes to -4. Now, you notice how we had a repeating x value here. That means that this is not a function. So this one was a function. This one was not a function. And this is called a one-to-many mapping diagram, because 1 point goes to multiple outputs. So 1-to-many represents not a function, okay? But really, all I really want you to focus on is whether something is a function or not. Does it have a repeating x value? So there's the mapping diagram. Now, I said we weren't going to practice graphing, but where does graphing come into play? Well, remember, if we graphed a bunch of points and we're looking for a repeating x value, what we're looking for is, since this is our x and this is our y, if let's say I have the point 3, 2 and 3, 5, we know that that's not a function because they're 3 repeats. Well, 1, 2, 3, 1, 2, and 1, 2, 3, 1, 1, 2, 3, 4, 5. We notice that when we map these 2 points are going to lie on top of each other. Or they're going to lie in a straight line, rather, a vertical line. So if we can draw a vertical line anywhere on our graph and it touches more than 1 point, that means you have a repeating x value. And that means that it's not a function. Okay? So if we look at these 2 graphs, this has no point that touches more than there. Therefore, there's no repeating x value. Same here, no repeating x value. Same here, no repeating x value. No repeating x value, and no repeating x value. Therefore, we don't have any repeating x value, and this is a function. But if we look here, no repeat here, no repeat here, no repeat here. These are all good. But this point right here, see how we have our repeating x value? That's represented by the fact that if I draw a vertical line, I'm going to hit more than 1 point. If you draw a vertical line and hit more than 1 point, it fails the vertical line test and therefore is not a function. Okay? And that is the difference between functions and not a functions, okay? So we're looking for that repeated x value. If the x value repeats in any way, whether it be graphically, an x value repeating means that a straight line would hit more than 1 point. If it's a mapping diagram, and on a mapping diagram, you have one area where an arrow comes off of each, or if you're just looking at your points and you see a repeating x value, then that represents something that's not a function. If no x value repeats, it is a function. And lastly, I just want to repeat the fact that the y value can repeat. So if you have 3, 2, 4, 2, 5, 2, 6, 2, doesn't matter that the y value keeps repeating, the x value does not, and therefore this would be a function. Okay? All right. Good luck. Go on, do your IXL and practice, and let me know if you have any questions. I'll see you live tomorrow during our regular scheduled period 2 class, where we're going to go a little bit more into graphing. Okay? And have a good day. I'll see you all tomorrow. Goodbye.